Welcome to Curie Electronics. In this video, we are going to solve Hsc 2022 Technical Assistant Electronics question paper. This exam was conducted on 22nd May 2022. And this part 1 video will cover first 30 questions. So first question, assuming C2 equal to 10 microfarad and other capacitors are all 4 microfarad, the effective capacitance between points A and B shown in figure. So this network is actually a bridge. It's a bridge combination. Bridge combination means we will draw a Beeston bridge using resistors. This is a similar kind of combination. And here he is saying C2 equal to 10 microfarad. So here C2 is the 10 microfarad one. Remaining all capacitors are 4 microfarad. And this is the A and B points. I'm not going in detail how to solve. That I will show you in another video in detail. So this same diagram can be, see, this is a balanced bridge because all are 4 ohm. If you take so this diagram we can draw it like this. How can we write? That is 4 microfarad capacitor, because all values are same, another 4 microfarad capacitor, and they are connected together. Here it is again 4 microfarad, 4 microfarad, 4, and here it is the 10 microfarad capacitor, 10 microfarad. This is A and this is B. Now, when we apply voltage source to this A and B, there won't be any current flow through this C2 capacitor. So that C2 capacitor can be removed from the diagram. The C2 can be removed. So for the remaining capacitors, if you see here top, 4 microfarad and 4 microfarad and 4 microfarad are in series. So when two capacitors are in series, their equivalent is C by 2. That is, we will get 2 microfarad. So the below arm also we will get 2 microfarad. Because the values are same, so it is C upon number of capacitors. So here C equal to 4 microfarad upon 2. So again we get 2. Now when two capacitors are in parallel, what happens? These capacitors will get added. So you will get finally CT equal to, that is 2 multiplied by 2. Number of capacitors equal to 2, and each capacitor is of 2 microfarad. You will get 4 microfarad as the answer. So option A, the answer is, for the first question, answer is option D, 4 microfarad. The next question, the temperature coefficient of resistance of a wire is 0.00125 per degree centigrade. See, it is in degree Celsius, degree centigrade. At 300 Kelvin, its resistance is 1 ohm. The resistance of the wire will be 2 ohm at the temperature. To solve this question, we should know one equation is there, that is RT. I will write it right top. RT equals R reference multiplied by 1 plus alpha, that is the coefficient of temperature. Difference between the at what temperature we have to find and the reference temperature, T reference temperature. This equation you should know to solve this question. Now, so RT, what is RT? He has given us 2 ohm. That is the 2 ohm is the RT here equals R reference. He has given, see that the reference resistance is 1 ohm, that was at 300 Kelvin. 300 Kelvin means 27 degrees Celsius. So R reference equal to 1 ohm multiplied by 1 plus, what is the value of alpha? 0.00125 multiplied by, inside the bracket what is there? This let it be a square bracket, that is T. T is the temperature we have to find, that is T minus 300 Kelvin, we have to write it in degree Celsius. So it is 27 degrees Celsius. Now we have to simplify. So 2 equals, if you multiply the entire square bracket by 1, we are going to get 1. So we'll just, our multiplication is done. Then 1 plus 0.00125 times T minus 0.00125 minus 27. If you multiply that, we will get 0.03375. We can multiply easily, okay? Just to save the time, I am writing it like this directly. So what is T? T equals, what will come? 1 plus 0.3375 upon 0.00125. So if you multiply by 10 to the power 5, both numerator and denominator, what do you get? 103375 upon 125. If you simplify that, you will get 827. This temperature in degrees Celsius. So to convert it into Kelvin, what you have to do? 827 plus 0 degrees Celsius equal to 273 Kelvins. 273. So we will get 900 plus 200, 1100 Kelvin, you will get it. So the answer is option B is the right answer. Next question. Vestigial sideband is most commonly used in, where it is used in television transmission. Two bodies A and B with masses in the ratio 4:1 are moving with equal kinetic energy. The ratio of the magnitude of their linear momentum is. So what is kinetic energy? That is Ke equal to half mv square. Now the same thing can be written as Ke equal to denominator and numerator I will multiply by m. Then this is the mv square. So what I will get? I will get 1 by 2m m square v square. So that is kinetic energy Ke equal to 1 by 2m p square. Mass into velocity is the momentum. Now what is P? P equal to square root of 2m Ke. Kinetic energy 2m Ke. So we have to compare here. So similarly, so if mass is, then we can write, if mass is m1, what we can write? P1 equal to 2m ke to m1 ke. Kinetic energy is same. So P2 equals square root of 2m2 ke. Now if you want to take the ratio P1 is to P2, what do we get? A root 2 m1 ke upon root 2 m2 ke. K is the kinetic energy. So everything will cancel out. What will be left out? Root 2 m1 upon root 2 m2. So now we got the relation P2 upon P1. No, P1 upon P2. P1 upon P2 equals what? P1 of root m1 upon m2. Now what is the question? Masses he has given 4:1. Equal kinetic energy. The ratio of magnitude of their linear momentum. So this is 4 upon 1 is the P1 is to. Then what is the right side? M1 upon M2. That is 2 upon 1, which can be written as 2:1. So 2:1 is the answer. Option C is the right answer. Question number 5. What is the output of the given C program? See here, how do you, he has initialized int I comma s1 equal to 0, s2 equal to 0. So these variables are initialized to 0. Then 6 in array 6 numbers he has stored. Now there is he is doing a for loop. There is a for loop. The number will get added to S1 if this operation, that is then this is the modulus operator, okay? That means 10 modulus 2. What is the remainder? Remainder is 0. If you divide 10 by 2, it is 0. Remainder is 0. That is known as the modulus. So if you execute that way, I don't want to go in detail. Here, if the modulus comes 0, then the value will get added to S1. Otherwise, it will get added to S2. So that is what it is doing. So like that, it executes, and the answer what you get is 36 and 39. Value of I0 plus for the system whose transfer function is given by the equation I of s equal to 2s plus 3 upon s plus 1 s plus 3. So this one, it is based on the initial value theorem. So this can be solved. I0 plus equal to a limit s tends to infinity s f of s. This is the initial value theorem. Now what is given? Limit s tends to infinity, s tends to infinity, yes. What is the f of s? F of s is given as 2s plus 3 upon s plus 1 s plus 3, which equals, now limit s tends to infinity, s is there. From the numerator 2s plus 3, I am taking s common. Then what should I write? 2 plus 3 upon s. Similarly, in the denominator also I will do. That is, from s plus 1, I will take s outside. Then I will write 1 plus 1 upon s. From s plus 3, I will take out s. Then I will write 1 plus 3 upon s. Now we will cancel it. This s and this s cancels. This s and this s cancels. Now we are going to apply the limit here, which is equal to limit s tends to infinity. That is 2 plus 3 upon infinity. 3 upon infinity means 0. So we will get 2. Now in the denominator, 1 plus 1 upon infinity. 1 upon infinity equal to 0. So we will have 1 multiplied by again 3 upon s equal to 0 because s is infinite. So again we will get 1. So what is the answer? We will get 2 is the answer. If a pole is added to a system, it causes lag compensation. According to Hsfc's criterion, the characteristic equation s to the power 4 plus 8s cube plus 18s square plus 16x plus 5 is. The answer is option D, stable. I have to revise how to solve this. For that I have take it granted from one of my friend. Okay, but answer is correct. It is stable. For an ideal voltage should have, this we know, ideal voltage should have very low, practically very low resistance. But for ideal voltage source, it should be 0 resistance. For a voltmeter, should be very high. Cells are connected in series in order to increase the voltage rating. When you connect a number of cells, the voltage rating increases. The rating of fuse wire is always expressed in amperes. 12. Question number 12. A wire of resistance 12 ohm is bent in the form of a circle. The resistance between the ends of the diameter. That means we have a wire like this. Okay. A wire of this is 12 ohm. 12 ohm. This wire, a wire of 12 ohm resistance. This is a wire bent in the form of a circle. How do you bend it? How do you bend it? From the middle, if you bend, you can make a, let me draw it. You can make a circle out of it. From the middle, if you bend, you will get a circle. Okay, it should be a circle. It's not drawn properly. The resistance between the ends of the diameter. So that means we can take any diameter. Okay, I will take this as the AB as the diameter. Now, if you see the 12 ohm resistance resistor, we have made it into a circle. So we have two semicircles. For each semicircle, what is the resistance? It is 6 ohm. Because the total length of the wire was 12 ohm. So we have made it into 2 6 ohm. And 2 6 ohms are connected in parallel. 6 ohm in parallel. Effective values, you know, RT equal to what? R upon N. So here R is 6 and N equal to 2. So you'll get 3 ohm. So the answer is option B is the right answer. Question number 13. The op-amp specification that limits the large signal bandwidth of an op-amp is. That is the slew rate. Slew rate is the right answer. Slew rate means how fast the output signal can change with respect to the input. So that what determines the bandwidth. In the output is 0 for like inputs and 1 for unlike inputs. In the statement is representative of which two input logic gate. This is easy. So we'll write the truth table for 2. 0, 1, 2 input gate. 1, 0, 1, 1. Now what is saying? The output is 0 for like inputs. So like input means 0, 0 or 1. 0 for like inputs, and for unlike inputs the statement for unlike inputs 1. So 1 1. So this is for the which gate? It is the XOR gate truth table. When inputs are different, output is high. The terminology of JKRST is used with reference to which of the following particular type of transducer? It is the thermocouple. J-type, K-type thermocouples are there. So it's a thermocouple. Question number 16. What is Thevenin equivalent voltage and resistance across terminal A and B? This question I tried to solve with KVL, but I got doubt. I was not able to get it properly. Correct answer. But when you try with KCL, it is easy. So we want the open circuit voltage. This is a 30 ohm resistor. Here we have the 5 amp source, 20 ohm resistor, and the other one 25 ohm is open, so we can neglect it. No need to take it. Now at this point, let us consider that the voltage is Vx. Vx is the open circuit voltage. And what is the current direction? The current is coming at this junction. Current is entering, so current should leave also. Now we can write current entering the junction equal to current leaving the junction. That is the KCL. So it is, you have to use KCL. So let me write it here. So 5 amp is the current entering. That should be equal to current leaving the junction. So Vx current, what is current leaving? That is Vx minus, this is a 5 volt. 5 volt upon, what is there? 30 ohm. So if you cross multiply, what you'll get? 150 equals Vx minus 5. So what is Vx? 155 volt. So Vx open circuit voltage, we got 155 volt. Now we have to find what is the equivalent resistance. Equivalent resistance, what you do? Voltage source, you have to replace it with a short circuit. So this is 25 ohm and this is 30 ohm. 20 ohm is there, but current source we have to open the circuit. So now what is the resistance? It is series. 30 ohm and 25 ohm are in series. So it is 55 ohm. So the answer is, the right answer is option B is the right answer. 155 volt, 55 ohm. So equivalent Thevenin circuit is one voltage source of 155 volt, 155 volt and 55 ohm resistor. This is the equivalent Thevenin circuit. Next question. The value of Z in the logic circuit is. So now to solve this, what I will do, only the A and B are same for both the gates. If this is now gate number 1, see if it is 1 and 2, both inputs are same. So I'll write the truth table, that is 0 0 0 1 1 0 1 1. For an XNOR gate, when both inputs are same, I will get high. So 1 I will get 0. Again what I will get? 0 1. For the second gate also I will get the same combination. For the second gate, what I'll get? 1 0 0 1. Now these are the inputs for the third output side, this gate, third gate. So third gate, that is also XNOR gate. So what happens? For both the input, for the third gate, inputs are same, 1 1 0 0 0 0 1 1. Then what will happen? Output is going to stay at 1. So output is going to stay at 1. So the answer is 1. Question number 18. In 50% modulated AM signal, the carrier is suppressed before transmission. The saving in transmitted power is, you see, the saving in transmitted power is given by PS, that is 2 upon 2 plus mu square multiplied by 100. there are different equation. We have equation for when full carrier is transmitted. Full carrier is transmitted. That is, we know PC equal to PT into PT multiplied by 1 plus mu square upon 2. Mu square upon 2. So if the carrier is suppressed, then what is the equation? PT equal to PC into mu square upon 2. From this we can find out. But the easy equation is the direct equation, that is 2 upon 2 plus mu square multiplied by 100. So 2 upon 2 plus 0.5 whole square multiplied by 100, which equals what you get, 200 upon 2.25. If you do that, what you get, 88.9% you will get. So the right answer is answer option A is the right answer. Consider the following 8085 instruction. Exclusive or XRA means exclusive operation. So after this operation, the accumulator should have 0. Then move MVI move immediate B to the register B. 4A is moved. So B is 4A. Subtract immediate 4H. That means from accumulator had 0 minus 4F. So we should get 4F with the carry flag set, with carry set. Carry flag set. With carry flag set. Then again what we are doing? We are doing the ANA, that is AND operation with B. AND operation with B. So this 4F has to be stored in the accumulator. 4F has to be stored in the accumulator. So with the 4F and B, we are doing the AND operation. 4F means 0 1 0 0. 4F means 1 1 1 1. 4F and what? 4F. And B, what is there? B, 4A. 4A is there in B. 0 1 0 0 A 1 0 1 0 is there. So this result has to be stored in accumulator. So it comes 0 1 0 1 0 1 0 0 1 0. So this is 4A. Once we do the AND operation, we are getting 4A. But what is the options? The content of register A and B are, content of register A is 4A and content of register B is same as 4F. But we don't have an option like that. I think this answer is none of these, because we should get 4A. Even I have little doubt regarding this question, because but I feel it is none of these only, because this 4A, 0 minus 4A, if that is equal to 4F with carry 1 with a carry flag set, then we should get none of these only the answer, because register A is 4A after the AND operation. Okay, let's move to the next question. An n-bit analog to digital converter is required to convert an analog input in the range of 0 to 5 volt to an accuracy of 10 millivolt. The value of n should be. So we should have a resolution of 10 millivolt. So that is 10 millivolt we need. Then what value we can choose? It should be 2 to the resolution is given by V full scale, that is 5 volt upon, we need this as 10 millivolt. For that 5 volt upon what we can take, 2 to the power, if you take 2 to the power 9, what we will get, let me see, once 2 to the power 9, what we can get. So a 5 volt upon 512. One second, my multi 512. It comes 9.7. It comes 9.7 millivolt. So the right answer is, this is the answer, C. Option C is the right answer. Question number 21. The diode logic circuit represented in the following figure is, this is we have two diodes, and this is the ground, 0 volt. Now I'll write the two tables, 0 0 0 1 1 0 1 1. What is going to be the output? If any of the input is high, if any of the V1 or V2, whenever V1 or V2 or both are high, we will get output as high, 1 1 1. Otherwise it is going, when both inputs are 0, the diodes are off, so we will get 0. So this gate is OR gate. Which of the following is not used as an RF oscillator? And the answer is Wien-Bridge oscillator, because Hartley, Colpitts are RF oscillators. Clap also a advanced version of, we can say advanced version of Colpitt. So Wien-Bridge oscillator is for the audio frequency, Wien-Bridge. The thermocouples are active transducers. Why they are active transducers? Because we need not to power the thermocouple. When there is a heat difference between the junctions, the voltage is produced itself. So it is an active transducer. Which of the following circuit components opposes the change in the circuit voltages? The change in circuit voltage is opposed by what? Capacitance. The change in current is opposed by inductor. It's capacitance. Fermi level of a p-type semiconductor is, so we have the conduction band and the valence band. For an intrinsic semiconductor, it is in the middle for the intrinsic. And for the p-type, it is a conduction band, then valence band. The Fermi level is just above the valence band. This is the Fermi level. For n-type, it is for the intrinsic, it is at the middle, Fermi level. And for n-type, it is just below the conduction band. For n-type, just below the conduction band. So for our question, the answer is just above the valence band for p-type. An amplifier power is changed from 10 watt to 20 watt. The equivalent dB gain will be, see, we have 1 watt. If you change this to 2 watt, it is a 3 dB change in power. One more, we have a 10 watt power amplifier and we are making it a 20 watt power amplifier. This is the change in 3 dB. It is power is the power doubling in watt is equal to 3 dB increase. So the answer, what is the answer? 10 watt to 20 watt. It is 3 dB. But if it is, we had 1 watt power and we made that amplifier to half watt, then it is decreasing. It is becoming half. Similarly, we have 20 watt, we had 20 watt, then we made it to 10 watt. Here also it is decreasing by half. This is the minus 3 dB change. This is known as minus 3 dB. Decreasing to just half is minus 3 dB. Question number 27. In which of the following power dissipation is lowest? CMOS is the one which takes least power for its operation. Question number 29. Gray code for 1101. See, gray code, how do you make the gray code right? For MSB, we'll just write it like that, 1. Then we do the ORing of these two. So 1 XOR, we'll do the XOR. 1 XOR 1 is equal to 0. Again, these two, if we do the XOR, what we get? We'll get 1. Again, these two, if we do the XOR, we'll get 1. So 1011 is the answer. SiO2. The SiO2 used as an insulator in IC fabrication or semiconductor device fabrication. Question number 30. In a radio receiver, the ability to reject the unwanted signal is known as, it is the selectivity. Selectivity means we can select at a particular channel and all the remaining frequencies should be rejected. So we have completed first 30 questions. I will try to upload the next part tomorrow. Let me see. If I find time, I will upload it. There I had two questions. One question I had doubt because that microcontroller 0 minus 4f, whether it is, I have taken it as 4f, whether it is correct or not. If you have any doubt, please comment in the, let me know in the comment section. If I have made any mistake, please point it out so that we'll correct it. Thanks for watching. If you like the video, please share with your friends. Don't forget to hit the like button.